Okay, once you've put your data into a summary table, it's going to make it a lot easier to not only draw a graph with it, but also to make some judgment calls on how reliable your data is. So what we've done here is, as we've shown before, our independent variable groups are up here, the different concentrations of salt in this case. And down here we have all our trials, and then we had to add in a few rows here of to signify how we're going to analyze this data. So we're actually going to pull some more information out of that raw data to help it make sense and draw a picture for us. The very first thing you always have to do is say average. Now in this case it's going to be average mass. And to get Excel to calculate that, it's really quite simple. You have to simply say equals and type in the word average, or even start to, and it'll assume what you want. You'll come up with all of these different options here. Average, we just want the basic one. Click on that, and then it says, what numbers do you want me to average? Well, you just have to highlight them by going like this. Highlight all of those numbers that you want to find an average for, close your brackets and go enter. And there you have your average. Now to save yourself some typing, you don't have to type that formula in over and over again. Highlight the cell that has the good formula. Go down to that bottom right corner and you'll see your cursor change. From here I want you to pull it across, click and pull it across, and it will copy the formula, but assume that you want to find the average of all the other columns in this table. And so that's exactly what it's done. It's, let me pull this down here. There, you can see my formula bar there. It's literally now finding the average of all of those other columns. If you double click, it'll highlight the columns for you that it's finding the average for, so you can see what data it's accessing to complete that function. So that's the very first thing you need to do, average something. Now you have to look at how far that data has spread out from that average. Were all your trials pretty close together, or did you have information all over the place? In other words, you weren't able to repeat the same trial and get the same answer. To do that, you need to find something called standard deviation. Now this is a link to the BIAL handbook that I have in your OneNotes, and they've got some fantastic in-depth analysis on how to do data and statistics and biology. So if you're interested in this, or if you ever need to do this at university, I highly suggest you go to this website. Standard deviation is basically looking at how far our data spreads from the middle number, from the average number. So most data, when you do look at it, it tends to follow what we call a normal curve. They don't always, but we're going to assume in this case that it is following what we call a normal distribution, and that most of your data falls in the middle, and then you have all these outliers of data that weren't quite the average, or either too big or too small. Standard deviation basically breaks your data up into 6 pieces, 3 on the bottom of the average, 3 on the top. And it groups the data. So it looks at 68.3% of your data falls into the first 2 pieces either side of the average. 95% of your data falls into the first 4 pieces either side of your average. And then this last little bit of data out here is the last 5%. And this data here we normally like to get rid of or ignore, because we always assume that the top bit of data and the bottom bit of data are so far away from the average that they have to have some error in it. So we usually ignore them when we're doing our statistical analysis. In junior science you call that top and tailing. So what we're going to be doing is trying to focus just on this middle data here, and we're going to get you to ignore the last 5%, the top 2.5% and the top bottom 2.5%. I'll show you how to do that in a minute. First of all, you just got to ask Excel to calculate what is your standard deviation. What is the size of every one of these increments? And so you do that simply by going equals again and getting Excel to find the standard deviation formula. If you type in STD, it will actually bring up all of the different types of standard deviation formulas it has. Select the one that's stdev.s. Okay, just the normal sample standard deviation. Double click on that And again, you need to tell it what numbers to go and find. Now don't touch your average. It's going to calculate your average when it's working this out. You simply have to highlight that column again, close your brackets and go equals, and it will work out your standard deviation. Again, copy it across. Now remember how I said we want to look at basically the top two and the bottom two standard deviations and ignore the last 5% of our data. Well, we do that by just finding out what two standard deviations is, because this is saying one standard deviation of our data is worth 0.07 away from the average. Two standard deviations, just ask it to find out what 2 times that is. 2, shift 8 to get your star, standard deviation, enter. There's what 2 standard deviations is. So now we're going to copy that across here. So you've got all of your standard deviations across. And you'll notice they do tend to change a little bit as we go. Okay, so we've got here standard deviation of 0.14, standard deviation of 6, standard deviation of 6, 0.1466. Quite a lot of difference in your standard deviations there, and that's essentially because we have a lot more error in some columns than others. Remember, standard deviations is a measure of how far the data spreads out from the mean, the average number. The bigger the standard deviation, the bigger the data is spread out, the more error you have. Okay? Now, once you've got those standard deviations, I'm just going to get you to write out your confidence limits. Now, remember, here we've got a picture here of the spread of your data. If I break this up into the 6 on the top and the 6 on the bottom, and yes, it's not fantastic drawing here, each one of these is a standard deviation. It's saying that, where am I here? Each one of these increments is worth, in the first one here, 0.7. 0.07. And it's saying that 95% of my data will either be below 0.14 grams below the average or 0.14 grams above the average. Another way of writing that is what we call a confidence limit or a range. Okay, where does 95% of my data, because the range of 95% of my data, it will be whatever my average is, it'll be 0.16 plus or minus 0.14 grams. So the lowest one here, if you take 0.14 off 0.16, that's going to be here I am remembering this on a Saturday afternoon, 0.02. And the highest of my data here that I want to accept is going to be 0.30. So that's my acceptable range. 95% of my data, it's going to range from 0.12 up to 0.30. Now I'm going to get you to type that range or that confidence limit where 95% of your data is in here. There is no formula, but you need to type it as text. So use one of your little text things there and type in 0.16 plus or minus 0.14, whatever 2 standard deviations is, and close off your text thing here. That just helps you to get a picture of your range, of how far your data is spreading either side of that mean. The smaller the range, the better your data. Make sure you put speech commas either side so that it treats it as text. This is just to get your head around how far your data is spreading. The bigger your standard deviation, the worse your data is. Put them all across here. Now, if you don't entirely get how to do all this well or understand what all of this means, it is something that you have to practice and learn before it really does start to click. For now, at least, just put in the columns, work it out like I've shown you, and we'll talk about it further in class. Okay, so the very last one you're going to be doing here is standard error. Now there is no formula for this in Excel. You actually have to type this in, so use the formula I give you in this video to work this out. Now standard error uses standard deviation to figure out whether or not your data is spread so far from the average that you can't really trust it or not. In science, we like our standard errors to be below 5%. Now that I've got you to look at standard deviation here and the confidence limits that we have on our ranges of data, we're going to see how this is now reflected in standard error. Now, to do standard error, you have to type in a very specific formula. First of all, you have to tell it to look at the standard deviation that you have worked out. So go equals, then click on your cell for standard deviation. And then you're going to tell it to divide that by the square root. So you have to type in SQRT, and it'll go, oh yeah, square root. Click that, square root of, now you're going to have to actually open up some brackets here. And now you have to tell it how many times you trialed this data, so how many trials you had. Now you can either type in the number of trials that you have here, or you can tell Excel to count them up. So I could simply type in 10 trials, okay, brackets 10, and close it, and it would find the square root of 10 and work it out. If I wanted to calculate it by counting them up, all I do is, instead of that, in my brackets I go count up all the numbers, or count up how many numbers I have, open brackets, in this section here. How many numbers do I have? 10. It'll still come back with 10. Put in 2 brackets to finish it off and go enter. There's your standard error. Now here our standard error is 0.02. Remember how I said that we like it to be below 5%? Well, this is 2%, so that's actually pretty darn good. Let's look at the standard error for the next one, however. I want you to move this over here till it gets to the black cross, copy it across, done. Look at the difference. The standard error for this one here was quite small. This standard error here is huge because we're literally doubling our data when we go either side of it. Our data is so spread out. 97% error here, 96 here, 2% here, 97, 96. Not really great error when you look at it like that. But at least we've got it there, because now we're going to use standard error and our average to make a graph of this so we get an idea of how this looks in picture form.